Hello class, here is another wonderful video with radicals, and this one is called dividing radicals. And this could also be thought of as rationalizing denominators. There's nothing fancy about any of this, so I'm going to go straight to doing some examples for you. Alright. So here's the first example that we're going to do together. I've got 2 over top of radical 3. The idea with dividing these things with radicals or rationalizing the denominator is typically when we're doing math with radicals, we don't want to have a radical in the denominator of our fraction. We want to get that out of there. Well, this is the way to rationalize denominators. Because this is a power of 2, all I'm going to do is I'm going to multiply this by radical 3, top and bottom, which is really the same as multiplying by 1. So I'm not really changing anything. I'm just kind of changing the way it looks. I'm not changing the value of the number at all. Okay. Remember, when we multiply fractions, we multiply straight across. So now I'm going to do the straight across thing. This is going to be 2 radical 3 on top. And then I've got radical 3 times radical 3, which is going to be 3 times 3, which is 9. Okay. Now let's simplify. This is 2 radical 3 on top, of course, because it doesn't simplify. But radical 9 is a perfect square, which is why we multiplied this by the radical 3, because I wanted a perfect square underneath it here so that I could get rid of it. So my final answer is 2 radical 3 over 3. Okay. Let's do another one. This one's slightly more complicated. This is radical 5m to the 4th divided by 4 radical 2m. No, I don't want to write equals yet. I want to multiply this. And I want to multiply it by whatever is underneath the radical. Whatever this radical is, I'm going to multiply that in the denominator. So I'm going to multiply this by radical 2m. Top and bottom, radical 2m. Now I've got the radical. 2 times 5 is 10. M times m to the 4th, that's 4 m's, that's 1 more m. That's going to be m to the 5th. Got the 4 times the 1 out here, that's just going to be 4. This is going to be radical. 2 times 2 is 4. M times m is m squared. There we go. Now let's simplify. The 10 won't simplify at all, so we're going to leave that underneath the radical. But the m to the 5th, well, that's m times m times m times m times m. There's a couple pairs of m's. I'm going to pull them out front, m squared, and I'm going to leave the m underneath that I have left. Now let's do the bottom. This 4 we know is a perfect square. That's going to be 2. 2 times 4 is 8. Then m squared, well, m squared is a perfect square because it's m times m, so then I'm going to be left with 8m on the bottom. You might be thinking, well, now we're done. Well, not quite, because we still have to simplify our fraction. Well, there's m times m up here, and there's an m down here on the bottom. So this is m times m, radical 10m, and this is 8m on the bottom. Well, there's an m up here and an m down here that I can cancel out. So now I get m radical 10m all over 8. Okay? Alright. Moving on. Look at this guy. This one is looking like tons and tons of fun. Alright. So this gets a little bit more complicated here because we have to talk about something called the conjugate. The conjugate of a number is just that number but the opposite sign. So this expression right here, the square root 5n squared minus 2n, I want to use the conjugate. In order to do the conjugate, I need the thing with the radical in it, or with the radical, to be the opposite sign. So I'm going to change this to this. Okay, so that I can think about this a little bit more easily. And I'm going to change that to the conjugate, and I'm just changing this plus sign to a negative. So negative 2n minus square root 5n squared is in fact the conjugate of this, because the 5n squared, radical 5n squared, is the opposite sign. Okay, so I'm going to rewrite this whole problem a little bit just to make it a little bit easier to do. Plus radical 5n squared. And then because I've got this, I have a binomial on the bottom, I have to multiply by the conjugate. Negative 2n minus 5n squared square root on top and bottom. So that doesn't change. Okay. Alright. Let's do the top first. I'm distributing the 3 through, so I get negative 6n minus 3 radical 5n squared. That's what I've got on top right now. Now, let's do the bottom. Negative 2n times negative 2n. This is just multiplication with radicals. I'm distributing everything through just like I normally would. Negative 2n times negative 2n is 4n squared. Negative 2n times negative 5n squared is plus 2n radical 5n squared. Okay, I'm going to do this one and this one, and this is why we do this, is because we're going to be able to eliminate this thing with the radical underneath. This is going to be negative 2n radical 5n squared. You can see that this now matches up. And then this times this is going to be negative radical 25n to the 4th. Okay, let's simplify that a little bit more. On the top, I've got the n squared. I'm going to go ahead and get that out of there. So now I've got negative 6n minus 3n radical 5. I've got 4n squared on the bottom. This is 2n radical 5n squared minus 2n radical 5n squared. These actually go away because when I subtract them, they're equal to 0. Then I'm going to be subtracting 25 is a perfect square, and to the 4th is a perfect square because it's n squared squared. So now I've got minus 5n squared. Simplify that a little bit more. 4n squared minus 5n squared is minus n squared. And then on top is negative 6n minus 3n radical 5. Believe it or not, this will simplify a little bit more. This has a 6n. The 6n has a 3n inside of it. So I can factor a 3 and an n out. So I'm going to take out the 3 and the n, and not only that, I'm going to take the negative out too. So I've got negative 3n times, this is going to be 2 plus radical 5 all over minus n squared. We're almost there. Negative and a negative make a positive. This has 1n in it. This has 2n in it, so I can take out an n. So now I've got 3 times 2 plus radical 5 all over n. Wasn't that fun? That was the greatest bit of algebra we've done so far, wasn't it? As you can see, these things can get pretty messy. Okay, here's this one. So the last one I'm doing in this video, I'm going to go through this one really quick. I need to multiply top and bottom by the conjugate. So I'm going to multiply this by negative 2p minus, because this is plus, radical 3p to the fourth. Negative 2p, not y, p. It should be a p minus radical 3p to the fourth. Okay, these are both binomials, so I'm going to be doing a lot of binomial distribution here. This and this is 4p squared. This and this, rather this and this is negative 2p radical 3p to the fourth. This one will be this. Sorry, I'm going fast, too fast. This should be plus 2p radical 3p to the fourth. This would be negative 2p radical 3p to the fourth. And then this one will be minus 3p to the fourth. You might be saying, what happened to the radical, Mr. Wicklehouse? Well, when I'm multiplying two things underneath, that's just going to become that thing. Okay, let's do the top. 2 times negative 2p is negative 4p. 2 times negative 3p squared is negative 2 radical 3p to the fourth. This one will be plus 6p radical 2p. This will be plus 3 radical 6p to the fifth. Alright, start combining things together. That and that goes away. 4p squared, negative 3p to the fourth. That's not going to combine together at all. So let's leave that one like that for right now. Now let's look at this crazy mess up here. Nothing really can combine together on all these. None of these all have p's in them. None of them all have 2's and 3's in it. So this is just going to be negative 4p minus 2 radical 3p to the fourth plus 6p radical 2p plus 3 radical 6p to the fifth. Okay. But there's some simplification underneath the here. P to the fourth, I can pull p squared out, so now I've got negative 4p minus 2p squared plus 6p radical 2p, because that one doesn't simplify any, plus 3p to the fifth. There's 2p squareds in there, so I can do that radical 6p all over 4p squared minus 3p to the fourth. And I see I finally have something I can bring out. A p, a p, a p, and a p. That's what I can bring out. I also have a p and a p down here, so I could get rid of a p on top and bottom. So that's going to be negative 4 minus 2p plus 6 radical 2p plus 3p radical 6p all over top of 4p minus 3p cubed. If you want me to slow that down a bit for you, then come and talk to me individually, and I will do that. This is about as complicated as we're going to get on these. I don't think there'll be too many that are like that, but you might see one or two, so I wanted to go over one that was slightly more complicated. Alright, that's it guys. I will talk to you later. Have fun.